Good evening, everyone. In the last session, we completed our project development. That project backend we developed by using Spring Boot and frontend we developed by using Angular. Now we are going to deploy this full stack application using Docker and Kubernetes. Front end of the project is developed by using Angular and backend of the project is developed by using Spring Boot. Now I want to deploy this application into Kubernetes cluster by using Docker. So here I have prepared the document step by step that going to help us to complete our deployment process. First, let us see. In this video, we will deploy one full stack project, Spring Boot plus Angular as Docker containers in Kubernetes cluster. Here we will complete our project setup process in 3 steps. In the first step, we are going to do environment setup. So whatever the machines that we need, whatever the softwares that are required, those things we are going to set up as part of our step 1. In step 2, we are going to deploy backend application that is developed by using Java with Spring Boot. Once backend application development is completed, then we are going to deploy our front-end application, which is developed by using Angular. All right. In order to do this, first, let's start with our environment setup. Set up Kubernetes cluster. Kubernetes cluster is a time-taking process, so I have not given that in the document. I have given you a separate document for Kubernetes cluster setup. Here I have Kubernetes cluster already configured in my AWS account by using KubeADM. One control plane available, 2 worker nodes are available. Let me start my Kubernetes cluster. Once the Kubernetes cluster is started, I will connect to this Kubernetes cluster by using MobiXTRM. I will connect with a control plane. My machines are getting ready. Give you a minute of time. Once the machines are ready, we are going to connect to that. Yes, my control plane is getting started. Control plane is going to act as master node in the Kubernetes. Fine. This is the prerequisite, guys. Kubernetes cluster setup is required. As I have that setup already, I'm using the existing setup. Let me connect with this machine by using MobiXTRM. You can use Putty also to connect with this. I'm using MobiXTRM. Remote host, username. I'm using Ubuntu machines for the cluster. So the default username of those machines will be Ubuntu. Select PEM file that we use to create those machines, aws.pem. Click on OK. All right. I have connected to this machine. Clear. kubectl get nodes. So if you execute this command, it is showing that how many nodes are available in my cluster. There are 3 nodes available in my cluster. 2 are acting as worker nodes and 1 is acting as master node. That is the prerequisite in order to set up this project. Environment setup. So Kubernetes cluster, I have that ready. Then second one, launch Ubuntu VM in AWS cloud in order to create the Docker images, and in order to push the Docker images, we need a machine with the Docker. You can take one Ubuntu machine and we can install Docker in that. Launch instances. Let me launch one new virtual machine in the AWS cloud. Let me name it as Ubuntu Docker VM. You can give any name for that. I'm giving as Ubuntu underscore Docker underscore VM. Ubuntu flavored Linux machine I'm going to take. In that machine, I'm going to install Docker. Ubuntu 20.04 LTS version that I'm taking. Ubuntu Docker VM. And T2 micro instance I'm using. Key pair, existing key pair I'm selecting for that. Default VPC, security group, I'm selecting my existing default security group. Then number of instances 1 only. Click on launch instance. With this one, new machine got started. In this machine, we need to install whatever the required softwares. Cluster is available. I already connected to my cluster. My cluster setup is working as expected. Now I have launched a new machine by using Ubuntu flavor. Now let us see Once this machine status is changed to running, then I will connect to this newly created machine also, and we will install required software in that machine. Yes, Ubuntu Docker VM is getting initialized. Let's wait for few seconds. Once that initialization process is completed, then we can access this machine as well. Yeah. Select this machine, select this Ubuntu Docker VM. This is the public IP, copy that public IP. Take a new session guys, SSH, remote host, username, Ubuntu is the default username, private key, aws.pem file I have used, click on OK. Now I have connected to this machine as well. I have connected to this machine as well. Fine. Now, once we connected to this Docker machine, we need to install Docker software in that machine because I need to create the Docker image for my backend application. I need to create the Docker image for my front-end application. Here I have given the commands. So by executing these commands, we are going to install Docker software. Yes, this is the first command which is used to download the Docker and execute that. Once we install the Docker, in order to use the Docker commands, we need sudo permission. Instead of that, I'm adding that user to the Docker group so that we can execute the Docker commands directly without using sudo permission. Okay, it is still downloading that. Once it is downloaded, I'm going to execute the remaining commands also. The remaining commands are, we are using the remaining commands to access the Docker commands without sudo permission. Right. Yes, it is done, guys. Now let's execute our second command, adding the sudo user, then new group Docker. If the Docker group is already available, then it will say that already existing. Then go for a Docker info. When I execute the Docker info command, it is giving the information about the Docker. We can also get the version of the Docker, which version of the Docker is installed. Okay guys, we can get the version of the Docker, which version of the Docker is installed here. We can simply get docker-v. So which version of the Docker? 20.10.22 build number also it is displaying. We are able to get the version of the Docker. With this Docker installation got completed. As my code is available in the GitHub, I need to clone my code from the GitHub repository and I need to build my code. As we discussed, backend is developed by using Spring Boot with Maven. We need to clone that code from the GitHub repository and we need to package that code by using Maven. So for that, we need to install Maven as well as Git client. So let me install them as well. Sudo apt install Git. First I'm installing Git client. It got installed. Sudo apt install Maven. I'm installing Maven. Click on yes. Perfect. So it is installing Maven. For Maven, Java is required. First it will install the Java, then it is going to install Maven. So with this, three things completed: Docker installation completed, Git client installation completed, and a Maven installation is in progress. So once this Maven got installed, then I'm going to install Node and Angular. For backend, we are using Maven. For frontend, we need to use Angular, right? Fine. Now here, I'm going to install Node. Once we install the Node, then by using that Node package manager, we can install Angular also. All right. Yes. Maven still in progress. It is taking time because first it has to install the Java, then it has to install the Maven, because Maven software is developed by using Java. Yes, completed. Good. Next, let's install Node and Angular. So to install them, I have given the commands here. Let's execute these commands one by one. Download NVM. It is a package manager. Done. NVM is installed, then bash rc. Next one, install the node by using NVM package manager. Install the node. It is installing the node version 19.3. Yes, completed. Once it is done, then we can check the version of the node by using node version. Yes, node version, we are able to check that. Node version 19.3, right here. And by execute that node version command here, it is displaying that node version. Perfect. Next one, npm install -g Angular CLI. So by using this node, I'm going to install Angular CLI software. The latest version of the Angular is 15, so it is going to install the 15th Angular version. For installing the Angular, we are using npm install -g Angular CLI. Yes, it is downloading Angular and it is installing that. Done. Angular got installed. Once Angular got installed, we can check that really that Angular version is installed or not. ngv. When we execute ngv, is asking a confirmation. Now, yes. Angular Analytics. Now you see Angular CLI is installed and Angular CLI version 15.0.4, that Angular version got installed. Perfect. Once this setup is completed, we are good to start. So Kubernetes cluster is available and Ubuntu machine I have created. In that Ubuntu machine, I have installed Docker, I have installed Maven, I installed Git client, and I installed Node and Angular CLI. So with this, we have completed environment setup to start our build and deployment. Clear? Good. Fine. Next one, backend application deployment. So first we need to deploy our backend. As discussed, backend application is developed by using Java Spring Boot. Let me clone my backend application. It is already available in the GitHub. I have pushed my code into GitHub repository. Let me take the GitHub repository of my backend application. Let me go to my repositories. In my repositories, github.com, my username in the GitHub is Ashok IT School. Here, contact backend application is available and contact UI application is available. This is a backend application. Let us access the URL and clone this URL in our Ubuntu machine. Now ls-l, currently there is nothing in my machine. It is a brand new machine that we have created just 5 minutes back. In this machine, Git is installed, Maven installed, Docker installed, Angular also installed. Let me clone my backend project first. Git clone repository URL. I'm cloning my backend repository. Here, once I have cloned, you can see that project ls-l contact backend application is available. Let me go inside that project, cd space contact backend application. I'm inside this project. Inside this project, src source folder is available, pom.xml is available. Target is not available. We need to clean package our Spring Boot application by using Maven. Let's execute the goal mvn clean package. When I execute mvn clean package, it is trying to download the required Maven dependencies and it is going to compile and it is going to package my application. So whenever it is compiling this and packaging the application, if you see in the pom.xml, I have given a final name. With that name, a jar file will be created for my application. The final name that I have given for this as contact-backend-app. So with that name, it is going to create a jar file for my application. Got it? It is still downloading the Maven dependencies. And it will package. Once it package our application, we can see the target folder will be created for the project. In the target folder, our jar file will be available. Once the jar file is available, then we can create a Docker image for our application. Got it? Yeah, guys. Still, it is downloading. First time we are doing the Maven build in this machine, so it is downloading all the required Maven plugins, Maven dependencies, and all. We have to wait. test goal is executing. When we execute package goal, internally compile test will execute. Now finally jar plugin is executing, which is used to package our Spring Boot application as jar file. Still it is downloading required dependencies. Finally, build success. Good. Now let us clear the screen. ls-l. Now if you see, target directory got created. ls-l space target. If you see the target directory here, our package file got created. Contact-backend-app.jar, our jar file got created. Once this jar file is ready, then we can start Docker image creation. All right. So now, first, before going to do that, let us check Docker images. Do we have any Docker images in our machine now? In our machine, Docker images are not available. Now to create the Docker image, we need a Docker file. So in the GitHub repository itself, I kept the Docker file also. By using that Docker file, we can create the Docker image for our application. In the Docker classes, we discussed that how to write the Docker file to Dockerize a Spring Boot application. From I am using as a base image, OpenJDK 11 I'm using as base image. I'm copying the jar file of our application from the target directory to container location user app. Once the jar is copied to user app directory, I'm changing the work directory to user app. Then by using entry point, I'm running that jar file. Spring Boot application will have embedded server. You don't need to deploy that application to a particular server because Spring Boot will have a embedded server concept. Whenever you run the jar file, Spring Boot application will execute in embedded Tomcat server. That embedded Tomcat server will run on the port number 8080. So I'm writing expose as 8080. This 8080 is our container port. So within the repository itself, I have given the Docker file also. You can see the Docker file content here, vi Docker file. OpenJDK, I'm using as a base image. I need Java to run this Spring Boot jar file. This jar file is prepared by using maven package goal. That jar file created in the target directory. From the target directory, I'm copying the jar file to user app location. Then I'm changing the work directory to user app, and entry point I'm using to execute this command when the container is creating. I'm executing this jar file by using java space -jar space jar file name, and container port number I'm giving as 8080. So with this, we have Docker file ready. Once the Docker file is available, we can build Docker image for this. I have given those commands also here. Once you have maven package ready, then this is the Docker file we need to write to create the Docker image, and these are the commands that we can execute to build the Docker image. Let me execute those commands. ls-l Docker file is available. Docker build -t image name contact backend app space dot. This is the command which I am giving to create a Docker image with a name called contact-backend-app. This is a contact book application. So I'm giving the backend application image name as contact backend app space dot. So with this, it is going to prepare a Docker image. It is going to prepare a Docker image. That a Docker image we can store into Docker Hub also. So I have a Docker Hub account. I will log in into my Docker Hub account and I will push my Docker image into Docker Hub so that anybody can access my Docker image. So still it is preparing our Docker image. Yes, successfully Docker image got prepared. Let's execute this command, Docker images command. Yes. By using OpenJDK as a base image, our application, backend application Docker image got created. Now I want to tag this Docker image, Docker tag. This is my image name. This is my image name. I'm tagging this with our username. So my username in the Docker Hub account is Ashok IT. I'm using Docker tag command to tag this. Once it is done, I'm going for Docker login. I will connect to my Docker Hub account, Ashok IT, and a password. This is my account credentials. You can give your account credentials there. I have logged in into my Docker Hub account successfully. Now I'm going to push this image to my Docker Hub account. So by using tag name, I'm going to push it. Docker push. It is pushing my backend application Docker image into Docker Hub account. That will be pushed as a public Docker image. Anybody can pull the Docker image and they can run my Docker image. By using Docker file, we created a Docker image. That a Docker image I stored into Docker Hub. That's it. With this, my backend application Docker image is ready. I have given the commands also clearly: Docker build command, Docker tag command, Docker login command, Docker push command. So once this Docker image is available, then we can pull that image and we can run that image. When we run that image, container will be created. I don't want to create the container manually. I want to create the container by using Kubernetes. So here we already have Kubernetes cluster. In this Kubernetes cluster, I'm going to create a deployment manifest file. By using that deployment manifest file, we can deploy our application as pods in the Kubernetes cluster, and we can expose our pods as a service. There are three types of services available in the Kubernetes. Node port service available, cluster IP is available, and load balancer is available. Now, in order to do the deployment of our application, we need a deployment manifest file. That deployment manifest file also I kept within the Git repository. So here a Docker file is available and a deployment.yml is available. If you go to deployment.yml, here pod manifest is available, and here service manifest is available. Pod manifest is available, service manifest is available. In the pod manifest, I'm giving the kind as a deployment. I'm giving 2 replicas, and here I'm giving the pod container specification, backend container, image name. Here contact type and backend app image is available. That is the local image. Now this application is pushed to, this image is pushed to Docker Hub account as a public image. I need to change the image name now. I will refer my Docker Hub image. And once this pod is created by using deployment strategy, then I'm going to expose the pod by using node port. Here in the service manifest, selector is available. This selector is a pod label. Here pod label I have given app colon contact backend, selector app colon contact backend. This is my deployment manifest. So deployment manifest is available and service manifest also available in the single YML. We already discussed how to write these manifest files. Copy this manifest file, go to Kubernetes. Here, let me create one file with a name called vi contact backend app deploy.yml. Contact backend app deployment.yml. So go to insert mode, keep this deployment manifest file. This image name, I have to refer my public image, Ashok IT / contact underscore backend underscore application. This is our manifest YML. This is deployment manifest. API version apps /v1. Kind I'm giving as a deployment. Metadata, I'm giving the name of the deployment. Specification replicas I'm giving to. Deployment strategy I'm not giving. So by default, it will consider the strategy as rolling update. And the match labels, I'm giving the label name of the pod. Pod label I'm giving. Template metadata, contact backend pod name, and this is a pod label, and this is a pod specification. I want to create a container. That container should be created by using my Docker image, which is already stored in the Docker Hub. That container will run on the port number 8080. So this image is representing a Spring Boot application. Spring Boot application will have embedded Tomcat server. The Tomcat server will run on the 8080. So container port number is 8080. Whenever you create the deployment for our backend application, 2 pods will be created because I have given the replicas as 2. Those pods cannot be accessed outside directly because we just created the deployment. In order to expose the pods, we are writing a service manifest. In the service manifest, kind I'm giving as service, contact backend service, service type I'm giving as a node port so that we can access them outside of the cluster also. So which pods it has to expose, that's where service selector is representing pod label. pod label name, service selector name should be same. Then only it can expose the pods outside the cluster. And port mapping I'm doing, my target port is 8080, that is my container port. And the node port I'm configuring as 30001. If you don't configure this node port, Kubernetes will take one random node port from 30,000 to 32,767 in between. So the range, that is the range of the node port. Here I'm fixing the node port as 30,001. So this is the deployment manifest to deploy my Docker image and into Kubernetes cluster as a pod. All right, save this. Before going to do this, let us check kubectl get pods. Do you see any pods in my cluster now? Kubectl get pods, it is saying that no services found in the default namespace. Kubectl get service, there is only one default service is available. So in my cluster, nothing is available now. Let me deploy this now. kubectl apply -f contact backend application deployment.yml. This is the manifest file we created now. I'm going to execute that manifest file by using kubectl. Kubectl is a CLI tool which is used to interact with the Kubernetes control plane. I'm telling to Kubernetes to deploy my application. Now see, deployment got created, and service also got created. Good. Let us check the pods. kubectl get pods. 2 pods are running. As you have seen, I have given the replicas as 2. 2 pods are created. Contact backend deployment, 2 pods are created. For the 2 pods, it has given some random ID. Let us check the service. kubectl get service. Yes. Contact backend service is exposed as a node port. The node port number is 30,001. That is the node port number which I have given in the deployment manifest. We can even see our pods are running, right? kubectl get pods. There are 2 pods are running on the cluster. In which node those pods are running? In our Kubernetes cluster, 2 worker nodes available, 1 control plane available. Where they are running actually? Get pods -o wide. So you can see pod is running on the node number 44, node number 69. So here you can check that in our cluster, 3 machines are there. 2 machines are representing as worker nodes. 1 machine is representing as control plane. So let me show you the IP addresses of them. Node worker node 1, 172.31.42.69. This is the private IP of my Kubernetes worker node 1. So now you see 172.31.42.69. In first worker node, 1 pod is running. And let me check the worker node, second worker node IP, 172.31.42.44. So 1 pod is running in the first worker node, 1 pod is running in the second worker node. For our application, 2 pods got created. For our application, 2 pods are created because I have given 2 replicas. So this is pod 1, it is in the running state. This is pod 1, this is in the running state. 1 pod is running in the first worker node, 1 pod is running in the second worker node. Can we try accessing our application by using any worker node? Take the public IP, go to browser, localhost. Instead of localhost, now we need to give the public IP of our node. The port number, node port number is 30,001. So when I access, yes, this is my Spring Boot application, URL pattern is not matching. If I give /contacts, empty contact array is coming because there is no data available in the database table. That's why empty array is coming. With this, can I say my backend application is working as expected, guys? My backend application deployment is working as expected. Yes, my backend application deployment is working as expected. It is running in the Kubernetes cluster. Okay, so here this is the Docker file. These are the commands to create the Docker image and Kubernetes control plane. This is the manifest file I am giving. Here you need to configure your Docker image name that you have created, and it is going to deploy your application on the cluster. These are the commands that are used to deploy our backend application on the Kubernetes cluster. kubectl apply command, get pods, pods-o wide, get service. We can see the service by using node IP. Sorry, this URL I need to correct it. Node IP : node port. So by using this URL pattern, we can access our backend application. So backend application is working. I'm able to see the URL of the backend application. This is the URL of my backend application. Now I need to deploy my front-end application. I need to deploy front end of my application. For front end application, Node and Angular CLI is required that we have already installed in our machine. Let me clone my front end application also. In order to clone the front end application, we are using GitHub clone command. So go to my GitHub repository. Here, contact UI application is also available. That is built by using Angular. Contact UI ng application. There is a Git repository for that. Take this Git repository URL. Now come to our machine where our Docker is installed. Come out from the backend application, ls-l. Here, contact backend application is available. Let me clone my front-end application. Git to clone front-end application. Copy the URL. Copy the URL. Git to clone repository URL. Yes, my UI application got cloned. ls-l. Yes, you can see UI application got cloned. It is developed by using Angular. Backend application part is completed. We already Dockerized and we deployed in the Kubernetes. Now we are going to Dockerize the front end and we need to deploy this front end application on the cluster. All right, front end application is available. cd space contact UI ng app. Once we entered into this front end application, we need to build this application and we need to Dockerize this application. Here guys, if you observe, there is a relation between backend application and front-end application. What is that relation? Front-end application should access the backend application. So front-end application should know the URL of our backend application. Front-end application should communicate with the backend application. For that, we need to configure the URL of the backend application in the front end. My backend application is deployed in the Kubernetes, so it is running successfully. We have seen the URL also. Backend application is running. Now I'm going to deploy my front end application also on the Kubernetes. When I'm deploying my front end application should access backend application. My front-end application should access backend application. So front-end application should have the URL of the backend application, then only it can access the backend. Okay guys, so when we developed the front-end application, we discussed that in the Angular service will be available. In the Angular service, we will write the HTTP client to access backend application. Got it? So what is the URL of my backend application? Let me take the URL. This is the URL of my backend. IP address. I'm giving the IP address colon that port. So this is the URL of my backend. This backend URL I need to configure in the front end application so that my front end application can communicate with the backend. That point also I have given in the notes. Once you have cloned Git repository of our front end application, then we need to configure backend application URL in the front end application. Go to front end application ls-l. Here src is available, source is available. Go inside that, cd source. Inside the source, app directory will be available. cd app directory. Inside the app directory, we have a file called contact service.ts. Service class in the Angular contains the business logic to interact with the backend. vi contact.service.ts. contact.service.ts. That file I'm going to edit. If you see in that file, here I have configured the URL of the backend. When I tested this application in the local, my backend and my frontend, I tested in the local. At that time, I have given localhost. Now the URL got changed. My backend is running in the Kubernetes cluster now. I need to configure that correct URL. Go to insert mode, remove this URL, and configure the actual backend URL. I'm configuring my actual backend URL. Got it? So http://13.235.18.151:30,001. This is the URL of our backend application. configure that. Okay, guys. Now save this file. Once this file is saved, then what is the next step? We need to build our Angular application. Go to project directory, then go to app directory. Inside the app directory, service file is available. Edit that service file, then configure backend URL in front-end application for integration. So backend is running in the cluster, Kubernetes cluster. Front-end application should access that backend application. That's why I have configured that URL. Once it is configured, now I need to build my Angular application. Once Angular application build is ready, then we can Dockerize our Angular application. Let's come out from here, come back to our root directory of the project, ls-l. Yes, good. I came out to project directory. To build the Angular application, we use one command called ng build. Ng serve is used to directly run the application. Ng build is used to build the Angular application. I'm executing ng build command. Yes, here the build is failed. It is saying that error, could not find Angular dev kit, build Angular browser, builders node package. So one of the package is missed here. That's why the build got failed. To resolve this problem, whenever we get this problem, we need to install this Angular dev kit package by using this command. npm install save dev Angular dev kit build Angular. I have given. If you get problem saying that could not find the implementation for builder dev kit, then execute below command to fix the problem. So when I am preparing this document, I got that problem, so I found the solution. So this command will resolve that problem. Let's try to execute this command. By using npm, I'm trying to install that Angular dev kit build Angular. It is going to take some time, guys. It has to download that. It has to download that. While resolving, npm install save dev npm install. This command also failed. Command with force, fix the upstream dependency conflict or retry. Legacy peer deps. Could not resolve this. npm install npm clean cache -force. It is failed. npm clean command. npm clean run now. 1 minute. No. npm install save dev Angular dev kit. I'm trying to install the dev kit, that is getting failed. Yes, we have to execute this within the project folder only. We have to execute this within the project folder only. npm install save. It is failing, or else let me do one thing. ng build. When I execute ng build, I'm getting this problem. Let me check the solution. Let's go to Google. I found the solution on this. Could not implement Angular build. npm install. I'm executing npm install command. Let us see. I'm trying to build this in the local, then I'm going to Dockerize. Instead of this, we can install the Angular and we can build this completely by using Docker file itself. That is also one of the approach that we can do. I'm trying to build this locally. I'm trying to build in my Ubuntu machine. Yeah, now let's see. It is generating the browser application bundles. It will take some time, guys. Ng build is in progress. Whenever we build this Angular application, it is going to create one dist directory that contains deployment. For the Java applications deployment, we are using Maven package. So it will build our Java application and it will prepare a jar file. So similarly, for Angular application deployment, we are going to use ng build command. For Java, jar file will be created. For Angular, JS files will be created for deployment. Those JS files will be created inside dist directory. Inside the Angular folder, inside the Angular project folder, we are executing ng build command. It will create one folder with a name called dist, that is distributed directory. Yeah, it is trying to build that application. We need to wait for that. So earlier, when I execute this command for first time, ng build, I got the issue. Then I have executed this command. After this, I got one more problem. Then I have executed npm install. I have executed one command called npm install. So I have executed this npm install command. Whatever the packages which are not up to date, those packages it has downloaded. After that, I have executed ng build command. Now it is saying that build is completed. Let's see ls-l. Now you can see dist directory got created. So whenever you build Angular application, dist directory will be created. Initially, this dist directory will not be available. If you see in the GitHub Angular application, we have only src and angular.json, package log.json, package.json. When I cloned my GitHub repository, dist directory was not available. That dist directory got created now when I do ng build command. When I execute ng build command, this dist directory got created. That is a distributed directory. ls-l dist. Inside the dist directory, my contact UI is available. So ls-l dist / contact UI. Excuse me. When I execute ng build, it created a dist directory. Inside the dist directory, my contact UI folder is created. That is my project folder. In that folder, index.html, main.js, polyfills.js, runtime.js, script.js, style CSS. Complete Angular project is packaged as JS files. Those JS files are created inside the project directory. That project directory is created in the dist directory. Now we need to dockerize this application and we need to run this Docker image as a Docker container. That container I want to run in the Kubernetes. For this, I have created a Docker file. The Docker file is given as part of the GitHub repository. So once you open Docker file, how we are going to Dockerize this Angular application? Here, I'm going to deploy this Angular application in the Nginx server. Nginx is a web server. In that web server, I'm going to run the Angular application. So Angular application is basically a HTML with JavaScript, right? TypeScript will be available. That a TypeScript is converted to JavaScript. HTML with JavaScript. So it is web page. The web pages can be executed by using Nginx server. So here I'm using base image as a Nginx. For Spring Boot application, we used base image as Java. For Angular application, we are using base image as Nginx. Nginx latest is a base image. When I have executed ng build command, dist directory is created. Inside the dist directory, our project folder got created. In that project folder, we have the content. Here, just I am giving two commands. One is from, I'm using base image as Nginx for Angular application execution. Copy whatever the content is available in the dist directory inside the project directory. Copy everything into container Nginx server. So user share Nginx HTML. This complete content of our contact UI, the project name, whatever the JS files which are created here, inside the disk directory, our project is available. Whatever the content is available, copy everything into Nginx. Nginx is a web server. Nginx server will run on the port number 80. So I'm giving my container port number as 80. This Docker file is very simple. So I'm using Nginx as a base image. I'm copying Angular application builder content into this Nginx server. That's it. Good. So this Docker file is already available. You can see the Docker file in our UI application, vi Docker file, same thing. From Nginx, copy dist directory project content into this Nginx directory. Expose 80. Nginx server will run on 80. Tomcat will run on 8080. Nginx will run on just 80. Good. So here, go to Docker images. Docker images. Earlier our backend image got created. Now I need to create front-end image. So here, if you observe Docker images command, my contact backend image is available and it is a tag name of that image. So to create the Docker image for the backend, OpenJDK we used. Now we need to build the Docker image for front end. Already Docker file is available, ready. In the dist directory, that distributed output is also available. Now build the Docker image. Docker build -t contact UI ng app space dot. This is the image name I'm using for my front-end application. Docker build -t contact UI ng app space dot. I'm creating a Docker image for my Angular application. Good. It is going to download that Nginx server and it is going to copy that content into Nginx server and it is going to build a Docker image. All right. So here I have given the Docker file also, guys. Once this Docker file is prepared, then we need to execute these commands. So to create the Docker image, I will push this Docker image also into my Docker Hub account. Then finally, we will deploy that in the Kubernetes. Docker image creation is in progress for front-end. Success. Docker image got created for front-end application. Let us see Docker images. Yes, we can see contact UI underscore ng underscore app, one Docker image created just 7 seconds ago. Let me tag that image, Docker tag. This is my image. I'm tagging with my username, Ashok IT / image name. Tag is completed. Then Docker push. I'm pushing this Docker image. Sorry. For push command, I need to give the image tag name. Docker push image tag name. I'm pushing this Docker image into my Docker Hub account. I'm pushing this Docker image into my Docker Hub account so that anybody can pull this image and they can execute it. Perfect. Here, let us go to Docker Hub and let us see the images are stored into Docker Hub or not. hub.docker.com. hub.docker.com. Let me log in into my Docker Hub account. Yes, this is my Docker Hub account. You see here, contact backend app. 28 minutes ago, I pushed this image, and contact UI ng app. Just a few seconds ago, I pushed this image. Contact backend app, Docker image is available. Contact UI app, front end image is also available. This is my backend image and this is my front end image. Now anybody can pull my images now. So once this image is ready, then what is the next step? The next step is deploying that on the Kubernetes cluster. Deploy that application on the Kubernetes cluster. And remember, in the front-end application, we already configured the URL of the backend application. My front-end application should communicate with the backend application. Perfect. Now, so here Docker image got completed. Now we don't need to deal with this machine. Docker machine work is completed. Go to Kubernetes. In the Kubernetes, how many pods are running? kubectl get pods. There are 2 pods are running. These 2 pods are for backend. Now let me deploy my front end. Let me deploy my front end application. For a front end application also, we need to have a deployment file. For front end application also, we need to have a deployment file. I think I forgot to keep the deployment file for the front end application here. Quickly, we can create the deployment file for our front-end application. Got it? Okay, let me go to this backend application YML. By using that YML, I will prepare the YML deployment manifest YML for front end also. Same file, same. I'm taking this file as a reference file, deployment.yml. Copy this file. Go to here, cluster control plane, vi, contact, ui, ng, app dot ng app deployment.yml. Contact ui ng app deployment.yml. So this is going to be my front-end application. Let me change the names. Contact backend app deployment, right? Let me give this as contact front-end app deployment. The label I'm giving as contact front-end. Here name I am giving as contact front-end. Label contact front-end. Contact front-end container. I'm going to create a front-end container. The image name, I need to configure the image name. The image is available in my Docker Hub account, Ashok IT. Contact underscore UI underscore ng underscore app. This is the image name. Let me check my image name. Did I give the correct image for that? Contact underscore UI underscore ng underscore app. Contact underscore UI underscore ng underscore app. Container port. This UI application running on the Nginx server. Nginx server port number will be 80. So I'm configuring the container port as 80. Okay, so observe what is the pod label, app colon contact frontend. That is the pod label I have given for that. Deployment name, contact frontend application deployment. Kind is deployment strategy. Container port 20. Frontend container and frontend application image name. Coming to service. So let me change the service name also. Contact front-end service. Node port. So what is the selector? Pod label. What is the pod label I have given? Here if you observe in the template, pod template, I have given the label as contact front-end. So same label I'm giving as a selector. What is the container port? Container port is 80. Node port, I'm giving 30,002. 30,001 is given for backend application. For front-end application, I'm giving the node port as 30,002. So this is our deployment manifest YML, and it is having a service manifest also. So with this manifest YML, front-end application will be deployed as pods with the 2 replicas. Those pods will be exposed as a node port with the node port number 30,002. Let me save this. Good. Let me execute kubectl get pods. There are only 2 pods, that 2 backend pods are running. Now let me execute kubectl apply -f contact underscore ui underscore ng app deployment.yml. I'm trying to deploy my front-end application on the cluster by using Docker images. Docker images are available in Docker Hub account. Let's execute. When I execute it, you can see deployment is created and you can see service is created. Let's get the pods now. kubectl get pods. Yes, perfect. 2 pods created 27 minutes ago. 27 minutes ago, whatever the pods are created, those are backend pods. 10 seconds ago, 2 pods created, those are front-end pods. Those are front-end pods. Got it? Are you able to see all the 4 pods are running? 2 pods are running from 27 minutes. The age of the pods is 27 minutes. Those are our backend deployment pods. 10 seconds ago, 2 pods created. Those pods are front-end application pods. Now let me execute kubectl get service. Yes. So backend service is running as a node port with 30,001 as node port number. Front-end service is running as a node port with the port number as 30,002. Now when I access this front-end application should communicate with the backend application. 2 applications are running on the cluster. Okay, guys. Now let us see where the pods are running. kubectl get pods -o wide. Now, if you observe, these two are first two are the backend pods. One pod is running in the first worker node, one pod is running in the second worker node. Same thing for the front end pods also, they distributed to two worker nodes. So this is one pod running in one worker node, and this is the second pod running in the second worker node. Once these pods deployment is completed, I have given front end manifest file also in the PDF document, guys. Whenever you deploy by using them, then we can access that by using node IP colon node port. If you remember, my backend application is running with the port number 30001, and my front end application is running with the port number 30002. Okay, now I'm going to access my backend application. I'm going to access my backend application. So let me access the backend application. Let me take the IP. So here already I have the IP. Let me take this 30,002. Perfect. When I access this IP, can you see whatever the Angular UI we have developed in the last session? Are we able to access that UI in the Kubernetes cluster? Are we able to access that UI in the Kubernetes cluster? Yes, it is accessible in the browser. Let me go to add contact. Let me add one contact, Ashok IT, contact number 1234567, something like that. Click on submit. Perfect. Whatever the contact I have added, that contact is displaying here. Let me go and add one more contact, John, john@gmail.com, and I'm giving some number for the John. Click on submit. So John record is also added. I want to change the contact number of the John. Click on edit. When I click on the edit, I'm giving the number 321123. Click on update. John contact number is updated. Let me click on delete for the John. When I click on John delete, I think there is an issue. Two records got, anybody deleted my record, guys? Anybody accessing my application? There should be only one record should be deleted, but two records are deleted. I think somebody is accessing that application. 123 321. 123 321. Click on submit. Yeah, somebody is accessing my application. The records are available now. The records are available now. So add contact, contact list, add contact list now. Our applications are executing now. Okay, guys. So my backend application is executing and my front end application is also executing. When I send a request for the front end application, that front end application is accessing the backend application. Both applications are running on the Kubernetes cluster. Now, in future, what we will do, whatever the URL is available for our front end application, then front end application URL, we are going to map with a domain name, www.gmail.com, www.facebook.com, www.naukri.com. Like the domain names will be available. Na? We are not going to share these URLs to the public. This IP address we are not going to share with the public. Okay, guys. So for the public, we are going to share a domain name. How to map this URL to a domain name? To map this URL to the domain name, in the AWS cloud, there is a service called Route 53 service is available. In the AWS cloud, we have a service called Route 53 service. By using Route 53 service, we can map our application URL to a beautiful domain name. Okay, that we will discuss in the AWS classes. Route 53 service is available. How to map our application URL to domain name using Route 53, we will discuss that. Perfect. So are we able to complete our backend deployment and front-end deployment by using Spring Boot, Angular, Docker, Kubernetes? Spring Boot we used for backend application development, a REST API we developed, and Angular we used to develop front end of our application. Docker we used to create the Docker containers and stored those Docker containers into Docker Hub. And Kubernetes we used as an orchestration platform. By using Kubernetes, we deployed Docker containers as pods in the Kubernetes cluster. So I have already shared this document with you people. By using this document, you can set up this project on Kubernetes cluster by using Docker. Are you clear? Perfect. Perfect. So this is the work that will be done by DevOps engineers in the industry. So developers will develop the code and the developers will keep the code in the GitHub repository. Then DevOps engineers are responsible to build and deploy our code into cluster. All right. Thank you guys.